Hello students, welcome back to Diksha Vedantu English for 9th and 10th. I am your chemistry master teacher Ankita. Today we are going to discuss the part 2, okay, the part 2 of the chapter Matter in Our Surroundings. This is a chapter from your 9th grade. So for state syllabus as well as CBSE syllabus, this is the first chapter in your syllabus. Okay, we will be understanding this chapter in depth, which is important for your NTSE exam, foundation, NEET exams, JEE, Olympiad, as well as NSTSE, KVPY exams. So the syllabus that's described in your textbook is not enough for your competitive exams. Okay, so you need to understand these concepts in depth. That's why I'm here. Yesterday part 1 is already done. We'll recap the part 1 whatever we have discussed yesterday, and we will move on with the respective concepts of today's class. Okay, let's get started. Hi, face dancer, hello. I hope you're doing great. So let's get started. All right. Yes. So please do subscribe to the channel if you haven't subscribed to the channel yet, and turn on the notification button, and we'll be coming live every single day. Don't miss out on the classes. And yeah. So making your grade 11 and 12 pathway easy, NEET, NSTSE, and NTSE, Olympiad exams. So we will be preparing you for these exams, for these competitive exams through our classes. Okay, these foundation classes. Do not miss out on that. Yesterday it's already done, Matter in Our Surroundings part 1. Today we'll be doing part 2. And 30th of March and 1st of April, we'll discuss the structure of atom, which is the third chapter in your CBSE board. Okay, CBSE syllabus. 2nd and 3rd, we'll discuss is matter around us pure. On 4th and 5th, we will be discussing the atoms and molecule chapter. Okay, let's get started with today's concept then. Let's recap whatever we have studied in the last class. That's very important. So physical nature of matter, the properties of matter have been discussed yesterday. Okay, so what are the physical properties of matter? So matter is made up of particles. The particles of matter are very, very tiny. These are extremely tiny. And the particles of matter have space between them. They have space between them. What do we call them? So interparticle space. Interparticle space. The particles of matter are continuously moving. They're always vibrating. Okay, they're always moving. They possess kinetic energy. They possess kinetic energy. In case of solids, it's quite less. Liquids, so quite more than solids. Gases have the highest kinetic energy. And the particles of matter attract each other. What is this property? This property is called interparticle force of attraction. Interparticular force of attraction. Force of attraction. Okay, these are the characteristics of matter, so which we have already discussed yesterday in detail, in depth, with some activities as well. Hello face dancer, hello, hi. Classification of matter. So there are 3 types actually. Classification as in the major ones are three: solids, liquids, and gases. Okay, and plasma, Bose-Einstein condensate. So this is not discussed in your syllabus in depth. Okay, only few of the points are given here, given about these two. But solids, liquids, and gases, these are extremely important. Okay, what is the characteristics? How do they how do they act? I mean, the gases, they have highest kinetic energy. These are all the things that we have discussed in the previous class yesterday. So solids, the characteristics of solids, they have definite mass, they have definite volume, they have definite shape, high density, and they are incompressible, and they are rigid. They do not have the tendency to flow. Okay, they are very rigid, and they have this property to resist the change in shape. Next, diffusion. So do not diffuse. What is diffusion? Diffusion is nothing but it is the phenomena of intermixing of particles of 2 different matters, or more than 2 different types of matter. That's diffusion. So as solids, in the solids, the particles are compactly arranged together. That is why solids do not show diffusion. And packing of molecules, these are closely packed. Intermolecular space, these are very low. and intermolecular force of attraction. There is very strong intermolecular force of attraction. That is the very reason why solids are going to have the tendency to show rigid nature. Okay. Next, molecular movement. So they only possess vibratory motion. Okay, so motion. And kinetic energy, very low kinetic energy compared to liquids and gases. All right. Moving on, liquids and gases, when it comes to the properties of liquids and gases or characteristics. So liquids do not have a fixed shape, gas also do not have a fixed shape. Compressibility less compared to gases. In case of gases, they are highly compressible in nature. And density, liquids have low density, gases have lowest density. What is density? Density is nothing but mass by volume. Okay, this is density. And fluidity, both can flow. Both are fluids here. Fluids are anything that have the tendency to flow. Okay. Next, kinetic energy of particles. It is higher than that of solids. Liquids have higher kinetic energy than that of solids, but highest is for gases. Next, diffusion. They show a fast diffusion, liquids. Because diffusion, how diffusion is going to happen? Monishri, we will be introducing you with the concepts for 11th and 12th. Okay. So we wouldn't be teaching the entire syllabus, but we will be introducing you with the concepts, the basic concepts and strategies to score marks for in 11th and 12th. Okay, Monishri. Hi. Vedantu, KRD ma'am. Hi. Yes. So diffusion, the liquids show fast diffusion and the gas do show fastest diffusion. So diffusion, how diffusion is going to happen? So intermixing of particles is nothing but diffusion. Okay. All of you please, answer in the class, live chat. So diffusion, what's diffusion? So this is, the interparticle space is responsible for diffusion. Interparticle space is responsible for diffusion and the particles move. The particles tend to move. These two are responsible. Okay. In case of solids, diffusion doesn't happen because there is no much interparticle space between the particles in case of solids. Okay. And also they do not possess, as much kinetic energy as that of liquids and gases. That is the reason. Moving on, interconversion of three states of matter. So we have discussed about melting, fusion, solidification, condensation and sublimation as well as deposition. So solid to liquid, it is called melting. What is it called? It is called melting. Liquid to gas, what is it called? Vaporization. Vaporization is of two types, boiling and evaporation. Next, we have solid to gas. Solid to gas is called sublimation. Solid to gas is called sublimation. Not all the substances can undergo sublimation. Gas to solid is called deposition. It is called deposition. Let me change the color. So gas to liquid is called condensation. Gas to liquid is called condensation. Liquid to solid is called solidification or freezing. Solidification or freezing. This is about the interconversion of three states of matter. So how do they do? How is it possible? We have to vary the temperature condition as well as pressure condition. Either of these can work for interconversion of states of matter. Okay. Thank you, Faced answer. Yes, formula for converting temperature. Celsius to Fahrenheit. You need to know all these formulas. Okay, you need to know all the formulae. So Celsius to Fahrenheit. Degree Fahrenheit is equal to degree Celsius into 9 by 5 plus 32. Fahrenheit to Celsius, degree Celsius is equal to degree Fahrenheit minus 32 into 5 by 9. So they have just, rearranged this. That's it. Next, Celsius to Kelvin. Kelvin is equal to degree Celsius plus 273. Next, Kelvin to Celsius, degree Celsius is equal to Kelvin minus 273. Okay. This is about the conversions. Thank you, Faced answer. Thank you so much. Moving on, do we always need to heat or change in pressure for changing the state of matter? Is it necessary? Do we have to vary the pressure or temperature in order to change the state of matter? Or it's just going to happen like that? What is the answer? Yeah, yes, we need to. Yes, okay. And yeah, I almost forgot, we have discussed about latent heat, guys, in the yesterday's class. This is also very important. Latent heat of fusion, latent heat of vaporization. Okay, now moving on. So evaporation and factors affecting it. In today's class, in the first half of today's class, we are going to discuss all these concepts. Okay, evaporation and factors affecting it. Evaporation is a type of vaporization, and difference between evaporation and boiling, and melting, freezing, boiling point, and factors affecting them. So what are all the factors that are going to affect the melting point or boiling point? So you might have observed that when you add salt to water, the boiling point will be increased or decreased. So what is going to happen? We'll discuss that. Okay, hi Tanushree. Hello. How was your day, Tanushree? Are you preparing for your board exams? It starts on April 6th, right? Yeah, we'll discuss this. Okay. Evaporation. You must have observed on a sunny day, wet clothes completely dries up after some time. Which process is involved here? Of course, this is summer and everybody would know this. Even if it's not summer, this is something that happens in each and everyone's day-to-day life, right? Evaporation. So evaporation is nothing but the phenomena of change of a liquid into its vapor at any temperature below its boiling point. The liquid is not going to reach its boiling point, but below the boiling point, if the vaporization happens, we call that evaporation. Okay, evaporation of seawater to obtain common salt. Next, evaporation of nail paint remover. So in nail paint remover, we have acetone. Acetone is very volatile. What is volatile? Anybody knows the term volatile? Volatile substances are those. So it's a final exams. Okay, cool. Yes. So what is volatile? Volatility is nothing but the tendency to evaporate. Okay. So the substances which evaporate very fast, these are called volatile substances. For example, alcohol, acetone, these are very, very volatile. Okay. So evaporation in case of, nail paint. Nail paint has acetone in it. Okay. So acetone evaporates. You can if you apply nail paint and if you want to remove the nail paint, you would know this. Okay. I'm really sorry, but Tanushree, I don't know. No one has blocked you from that account. As far as I know, I haven't, because you were answering yesterday very well. Why would we do that? Of course. I'm not sure, but we'll ask the channel manager tomorrow. Okay. So everybody is on, today is holiday, right? It is Good Friday. So we'll ask the manager tomorrow. Okay. Yeah, you can chat from this account as of now. We'll discuss that tomorrow. Okay. It's no longer with you. Okay. We'll discuss that. We'll resolve that issue tomorrow, Tanushree. Okay. As of now, please, chat with us, answer through this account. I would really appreciate it. Yeah. Evaporation of water from the surface of a pond. This is also an example for evaporation. And what are the factors that is going to affect your evaporation, temperature condition. So rate of evaporation is directly proportional to temperature of the liquid. Okay, so hot water will evaporate more quickly than cold water, and when the temperature increases, so it is going to, it's not sending. Okay, there must be some error. We'll check that. Okay, we'll do that tomorrow. So I will not be able to access the channel, so I'll see tomorrow. Cool. Yeah, as the temperature increases, the rate of evaporation increases. As the surface area of the liquid increases, the rate of evaporation also increases. So what is surface area? I'll give you a very simple example here. So when you when you unfold the cloth and dry it, it's going to dry out faster, at a faster rate. But when you when you are not going to unfold the cloth that's already wet, the evaporation, the drying of clothes is going to take a longer time. So that's the best example. So when you unfold the cloth, the surface area is more. Okay, as the surface area increases, the rate of evaporation increases. Okay, the rate of evaporation increases. Moving on with the wind speed. So rate of evaporation is directly proportional to wind speed. So this is something that we used to do even without knowing evaporation. So whenever there was rainy days, back at my place, it rains cats and dogs. Okay, so I used to dry my clothes inside the room, switching on the fan. I didn't even know. So evaporation is responsible for all these things, and have factor. There are few factors which influence evaporation. So this is something that we use in our day-to-day life, right? As the wind speed increases, wind current is more, then the evaporation will be more. So clothes on a clothesline will dry more quickly on a windy day than on a still day. Why? The wind is going to carry away the water vapor, okay, that is present in the clothes. Next, humidity of the air. What is humidity? Humidity is nothing but the moisture content present in the air. This is the moisture content in the air. So if you go to coastal areas, you will feel the humidity. You're always sweaty. It's sticky, right? Why? Because the humidity is more. Along with the temperature, the humidity is very much. Okay. So as the humidity increases, the rate of evaporation decreases. Why? There is already moisture content in the air, right? So what is the point? How can evaporation occur faster when there is already air that is saturated with moisture? Okay, so all the other three factors are going to, temperature, the wind speed, and also we had surface area. These three factors increases the rate of evaporation, that directly proportional to the rate of evaporation. But humidity is a factor which decreases the rate of evaporation. It is inversely proportional to the rate of evaporation. Next, evaporation causes cooling effect. This is something that you can observe around pond areas, or any reservoir, freshwater reservoir. So what is it? When we put acetone on our palm and wave it around, acetone evaporates rapidly and a palm feels very cold. So liquid absorbs latent heat of vaporization of gas. The liquid is going to absorb the heat from the outside and it is going to vaporize. It is going to evaporate. Okay, the latent heat of vaporization is lost from our palm, which gives us the cooling effect. So evaporation causes cooling effect. They might ask you why. Why? So liquid absorbs heat, latent heat of vaporization of gas. The latent heat of vaporization is lost, okay, from the substance. Substance as in case of palm, when we put acetone on it, so latent heat of vaporization is lost from a palm, is given from a palm. So it produces a cooling effect. Okay. In case of ponds and rivers, the heat is absorbed from the outside. That's why it causes a cooling effect. Okay. So now earthen pots keep water cool during hot summer days. Perspiration is our body's method of maintaining a constant body temperature. What is perspiration? Sweating. Okay, a fancy word for sweating is perspiration. So this is also an example for the evaporation causing cooling effect. Why do clothes dry slowly on rainy day? Due to decrease in humidity, due to increase in humidity. Why? So during rainy days, the moisture content will be more. The humidity will be more. Is that the reason why? So the clothes dry slowly on a rainy day. Yes. Answer the question. Okay, that's cool. Okay, cool. We'll resolve that issue by tomorrow, Tanushri, okay? Yeah. Due to decrease in humidity? No, it is due to increase in humidity. This is the right answer. Okay, option B is the right answer. The rate of evaporation increases with decrease in humidity of air. But on a rainy day, humidity is more due to which rate of evaporation decreases and clothes dry slowly. Moving on, which one affects the rate of evaporation? Pressure, wind speed, density, fluidity. Which is going to affect the rate of evaporation? What is the answer? What's the answer? Pressure? No, pressure has no role in affecting the rate of evaporation. Wind speed, yes. Density, no. Fluidity, no. Okay, option B is the right answer for this question. Next, why should we wear cotton clothes in summer? So, what is the reason that we wear cotton clothes? Because cotton clothes can absorb the sweat and it gives the cooling effect to the body. Okay, unlike nylon or polyester. Okay, that's why. Next, why the water kept in earthen pot gets cool during summer? Why? The earthen pots will have small pores or holes. Pores or holes. So, the water is going to observe the temperature, okay, and it causes a cooling effect. Okay, evaporation causes a cooling effect. For both of this, the basic thing is about evaporation. Evaporation causes cooling effect. Very good, Tanush. You're absolutely right. Question number, yeah, there is no question number, but these are from your previous year papers, okay, from your competitive exams. Is went through those pores. Absolutely right. Very good, Tanushree. Which condition out of the following will increase the evaporation of water? Yes. Increase in the temperature of water, decrease in temperature of water, less exposed area of water. None of these. We'll try eliminating. Okay. Let's see. None of these we don't know. C, less exposed surface area. No. So, as the surface area increases, the rate of evaporation increases. Okay. Next, decrease in temperature of water. No, this is wrong. Okay. As the temperature increases, the rate of evaporation increases. And there we have the answer by Tanushri. Very good, Tanushri. It is option A. Okay. It is option A. I told you yesterday also, use elimination method to conclude with the answer. Okay. To get the answer in case of MCQs. Which condition? Yes. Look at the following figures and suggest in which of the following vessels A, B, C or D the rate of evaporation will be the highest. In which one? The vessel is closed here. Okay. It's a small vessel. These two have, the more surface area. Same surface area. But there is a fan in case of C. Very good, Tanush. Your absolute cooperation. Is it option C? Absolutely, yes, it is option C. Very good. Keep it up. Option C is the right answer. Tanushri, you gave the right answer. Why did you retract? Yeah, it is option C. Next, difference between evaporation and boiling. So we already, discussed a bit about difference between boiling and evaporation in yesterday's class. Do you want to answer? So what is the basic difference between evaporation and boiling? Both are vaporization. Types of vaporization, right? In both the case, liquid is going to change its state to gas. Yeah. Yes, what is boiling is hotting the water. Okay. So boiling occurs when a liquid reaches its boiling point, Tanushree. You're almost there. Boiling occurs when the liquid is going to reach the boiling point. There should be a specific temperature. There will be a specific temperature for a liquid to boil. Okay, what is boiling? The bubbles are going to form. That's boiling. Okay, so water to gas. Yeah, so we'll discuss this. Okay, so you must have observed boiling point of water, right? Liquid, boiling of water, liquid state changes into gaseous state, water to steam is going to happen. Bubble forms throughout the bulk of the liquid. If you record the temperature of the liquid, it is 100 degrees Celsius. So you all have seen boiling. Yes, boiling point of water. Tanushree, be more specific, okay? Different liquids have different boiling points. For example, water has 100 degrees Celsius boiling point, but ethanol boils at around 70 degrees Celsius. Okay, so it changes from one liquid to another liquid. So boiling point of water is 100 degrees Celsius. Melting point of water is 0 degrees Celsius. Okay, melting point or freezing point of water is 0 degrees Celsius. Yes. So we can say boiling of water is 100 degrees Celsius. During boiling, temperature increases, kinetic energy of all the particles increases. So it is a bulk phenomena. Every particle that is in that substance is going to attain the boiling point and they are involved in boiling. But in case of evaporation, only the particles that are at the surface. Suppose this is a container. It has water in it. Okay. So evaporation is going to happen only for the particles that are at the surface area. But boiling occurs throughout the sample. It is a bulk phenomena. Okay. Kinetic energy of all particles increases. Interparticle force of attraction decreases. It drops. And liquid changes into gas. This whole process is known as boiling. Okay. It's known as boiling. You must also have observed when a liquid is left exposed to air, its volume decreases gradually. So in this case, boiling is happening. No, it is evaporation because the liquid has not been heated. Okay, so using any heating devices. But as the temperature increases and as the flow of air increases, evaporation happens. Why? The liquids at the surface, the particles at the surface are going to attain more kinetic energy, and it is going to change its state. Okay, very good. The particles move very fast than normal while the water is boiling. Absolutely right, Tanushree. Yes, as the temperature increases, of course, the kinetic energy increases. Kinetic energy increases means the particles are moving very, very fast. Yes, the process of evaporation can be explained as surface particles of liquid have more kinetic energy than the others in bulk. Okay, so evaporation is a surface phenomena. Boiling is a bulk phenomena. Bulk means all the particles are involved in boiling. Okay, bulk phenomena. Yes, surface particles of liquid have more kinetic energy than the others in bulk. So even below its boiling point, particles have enough energy to break the force of attraction between them. The particles escape from the surface of liquid in the form of vapor. So liquid to gas is going to happen. So this process is known as evaporation, and the evaporation is a surface phenomena. They might ask you this question: why boiling is a bulk phenomena, evaporation is a surface phenomena? Okay. Tanushree, there are already classes up in the channel. You can check that out. Okay, for 9th grade. For 9th grade it's not done, but Neha ma'am will be soon starting that. Okay, don't worry about it. She'll be starting as soon as possible. Next, difference between boiling and evaporation. We can now define boiling and evaporation, right? Boiling is the process of liquid changing into vapor when a liquid is heated to its boiling point. Evaporation, on the other hand, is the process of a liquid changing into vapor even below its boiling point. So evaporation can happen at any temperature below the boiling point. Tanushi, for 10th grade, we only did social science. Me, Neha ma'am and Navya ma'am. But for 9th standard, we haven't started it. We'll be starting, after the school commences. Okay? But we can conduct week quizzes for 9th graders if you need. Next, method of change of state in case of boiling takes place from the whole liquid mass, which means that in bulk. But evaporation takes place from the surface of the liquid. It is a surface phenomena. Next, temperature takes place only at the boiling point of the liquid. Boiling occurs at boiling point. Okay? Not 9th class. You want social science for 10th class only? We have already done it. Tanushri, we took 8 hours marathon. You can check that out in our channel. Okay, go to the playlist and check that out. Okay, we have done it like 2 weeks ago. We also conducted week quiz. We also conducted PYQs. Yeah. So bubble formation, bubbles are formed in the liquid. No bubbles are formed in the liquid. In case of boiling, bubbles will be seen. But in case of evaporation, bubbles will not be seen. And the speed of the process is rapid. Vaporization happens at a rapid speed in case of boiling. But in evaporation, so vaporization is quite slower. The evaporation process itself is slower than that of boiling process. Next, heat. Source of heat is required. Okay, we need to heat the mixture using a heat source, an energy source. But for, evaporation, heat is supplied by the surrounding. It will be supplied by the surrounding. Okay. Yes. Moving on. Boiling takes place at dash any given temperature. Boiling point of liquid. What is the answer? This is very simple. Trust me, they're not going to give you this easy of a question in your competitive exams. Yeah, it will be done again. Tanushri. Yeah, we will conduct all the sessions again, live classes preferably, okay, for the next batch. But we'll be starting that in the month of May, because the school is only going to commence after May, right? That's why. Is it option A? Come on. Is it option A, Tanushri? Boiling. Boiling takes place at dash. At any temperature? No. At the boiling point of the liquid. Okay, option B is the right answer. Option B is the right answer. Okay, B. Yes. Next, during evaporation, particles of a liquid change into vapors only dash from the surface, from the bulk, from both surface and bulk, neither from surface nor from bulk. What is the answer? What is bulk? Bulk means the whole of the substance. Bulk means whole of the substance. Okay, for example, here we have a vessel. Okay, there is some substance here. Let's say acetone is there. Acetone is there. Okay, if whole particles, all the particles in that substance, all the particles in that vessel is going to take part, then we call it bulk. Okay, all of it. Only if the surface particles are going to interact, it's called surface phenomena. Okay. Yes. No, it is the surface. Okay. During evaporation, so it is a surface phenomena. That's why only the particles from the surface of the liquid is going to take part in evaporation. It's not C, it's not A, it's A. Okay. From the bulk, so it is boiling. Boiling is the bulk phenomena. Evaporation is a surface phenomena. Okay, don't get confused. So boiling happens, as a bulk, as in each and every particle in that matter is going to start boiling, is going to attain that temperature and start boiling. But in case of evaporation, only the surface, the particles that are at the surface are going to absorb the energy and they are going to start moving at a faster rate. So the kinetic energy increases. The kinetic energy will be used to overcome the force of attraction between the particles and change their state. Understood? Alright. So Hema option A is the right answer. Yes, very good. Very good. Next. Boiling is a surface phenomena while evaporation is a bulk phenomena. True or false? Is this true? Answer. Is this true? No. Very good. Dhanushri, very good. It is false. Okay. So boiling is a bulk phenomena. This is ulta. Boiling is a bulk phenomena. Remember this. BB. Boiling. Bulk. Boiling is a bulk phenomena while evaporation is a surface phenomena. Evaporation is a surface phenomena. It's a surface phenomena. Okay. Exact opposite. Very good, Hema. Very good. Both of you. Varshini, Tanushri and Hema. Okay, you two know each other. Tanushri and Hema, Varshini. Yeah, which property of water changes during evaporation? Which property of water changes during evaporation? Yes, give me the answer. State of the water changes. Okay, state it is. So liquid to gas. So state of the water changes during evaporation. Next, does boiling lead to evaporation? Does boiling lead to evaporation? You cannot understand the question. Okay, so we'll discuss that. Yes, you cannot understand the question. Okay, what property of water changes? The composition changes? No, the state changes. From liquid to water will be converted into steam, right? The state of the water changes. Physical state of the water. Okay. So, does boiling lead to evaporation? Will it lead to evaporation? Both are vaporization. So, yes. Okay. Now, moving on. Dash is a bulk phenomena. Evaporation, boiling, both boiling and evaporation. None of these. What's the answer? Is it B? Yeah, very good. Boiling is the right answer. Very good, Tanushri. Very good, Hema. Dash is a bulk phenomena, so boiling is a bulk phenomena. Which of the following phenomena is based on the principle that cooling results due to evaporation? Formation of water drops on the surface of cold drink bottle. Formation of crystals of ice on the inner surface of the lid of an ice cream box and freezer. White foggy appearance on the surface of large ice blocks. Stretching out of tongues by dogs during summer season. Yeah, tell me the answer. This is quite tricky. This is from previous question paper. Yeah, which of the following phenomena is based on the principle that cooling results due to evaporation? Even when we eat something really, really spicy, what do? We do this. Why? Is it E? Is it B? What is the answer? It can't be both B and D, right? Yeah, option D is the right answer. Both of you very good, Varshini and Tanushree. Option D is the right answer. Stretching out of tongues by dogs during summer season. What about this then? Formation of water drops on the surface of cold drink bottle. What is happening there? This is condensation process, guys. Condensation. In condensation, gas to liquid is going to happen. Okay. Formation of crystals of ice on the inner surface of the lid of an ice cream box in freezer. What is that? Formation of crystals of ice. That is solidification. Solidification. Okay. Next, white foggy appearance on the surface of large ice blocks. White foggy appearance. What is that? Condensation, freezing. Very good. Yeah. So when we have large ice blocks, when it is kept outside in the in a room, so not in the fridge but in the room, the temperature difference will be there, right? So that temperature, the coldness of the ice will be released to the released in the room, which means that what's happening there, ice will start melting, right? Ice will start melting. So it's gonna be, it's not sublimation, no. It's not sublimation. Ice, yeah. The foggy appearance. What is it because of? Solidification and fusion, same. No. Melting and fusion are same. Tanushree. Melting and fusion are same. Melting or fusion. Sorry. Melting. Yeah, melting and or fusion. Correct. Solidification. What is solidification? So solidification is when a liquid becomes solid. That is solidification. Okay. Yeah, solidification and freezing are same. Absolutely. Solidification or freezing. Freezing or solidification, melting or fusion. Both are same here. Okay, melting or fusion, freezing or solidification. Not all the substances can undergo sublimation. Okay, so can you give me examples for the substances which can undergo sublimation? Yeah, any examples? Come on, give me the answer. C is deposition. No. Deposition is a phenomena where, let me write here. Yes, deposition is a phenomena where a gas will be converted into a solid. Solid to gas is what is it? Solid to gas is sublimation. Yes, NH4Cl, very good. Ammonium chloride, camphor, yes, naphthalene ball, dry ice, absolutely right, very good. I almost gave all the examples. Yes, very good, very good. What is dry ice? It is solid carbon dioxide. It's solid carbon dioxide. Moving on. Yes, dogs stretch out their tongues during summer season because the surface area of tongue provides scope for evaporation, which protects the body from overheating during summer and give them a cooling sensation. This is because they cannot sweat like human beings. I don't know about sweating situation in case of dogs and human beings. I mean difference, but I do know that this is evaporation is responsible for cooling effect. Next, and factors that are going to affect them. Name the process when a liquid changes into vapor while heating the liquid to its boiling point. What is it? Very simple, guys. It's very simple. This is boiling point. Sorry, boiling. The process is boiling here. Okay. So solid to liquid change. It's called melting. The process of ice converting into solid is called melting of ice. Melting or fusion is a physical process which results the phase transition or change of state of matter of a substance from solid to a liquid. Okay, the temperature at which solid changes into liquid at atmospheric pressure is called melting point of the substance. See here, melting of candle. In candle, what we'll have? Wax. Okay, and wax is a hydrocarbon. So what are hydrocarbons? We'll be discussing that in your 10th grade. 10th syllabus, you have hydrocarbons even in first PUC. Okay, so melting butter in a hot pan. So this is also hydrocarbon. Okay, so melting of butter. Okay, the melting point have to be reached. Melting point needs to be reached. Okay. My name is Ankita Varshini. I'm Ankita. I teach chemistry and sometimes social science during exam times and sometimes English as well. Yeah. So ionic bonds, factors. So factors affecting the melting point. What are ionic bonds? Do you have any idea about ionic bonds? This is something that you will study in your 10th grade, but this will be there for your competitive exams. Okay. As the ionic nature increases, the ions, very good. Yes, ionic bond happens because of ions. So losing or gaining of, electrons leads to ion formation. And if there is a bond that exists between a positively charged ion and a negatively charged ion, we call that ionic bond. Okay, very good, very good. Anions and cations, absolutely right. Very good, Varshini. Very good. Yes, as the ionic nature of a substance increases, the melting point also increases. Okay, the melting point is directly proportional to the ionic nature. Next, intermolecular forces. So melting point is directly proportional to intermolecular force. Why? See, if there is more intermolecular force, we need to provide more energy to break the bond and melt the substance. So it makes sense, right? So intermolecular force is directly proportional to the melting point. Okay. In case of here, sodium fluoride. So sodium is positively charged, fluoride is negatively charged. There exists a ionic bond and it will have a very high melting point. Okay. And here in case of intermolecular force, in case of what is this? H2O, right? So what's happening here? The melting point is not quite high for water. Okay, that is ice. Why? Because there is no much intermolecular force of attraction in them. Okay. Yes. Presence of impurities. Melting point is indirectly proportional to the amount of impurities. Okay, indirectly proportional means melting point increases as the amount of impurities decreases. Impurities decreases, which means that, so if there is less amount of impurities, melting point will be more. Okay, melting point will be more. Example, this phenomena is used in making the freezing mixture by adding salt to ice to keep ice creams frozen. Okay, so ice creams will be added with some amount of salts so that it wouldn't melt easily. Salts are the impurities, right? Salts are the impurities. As the amount of impurities increase, what is going to happen? The melting point is going to decrease. Okay. Next, effect of pressure. The effect of pressure on melting point of solids depend upon the nature of the solid. For example, substances,
Hello.
So substances that expand on melting, so melting point is directly proportional to the pressure. Okay, for example, silver, it expands on melting. So the pressure influences this melting point. So as the pressure increases, the melting point also increases. Okay, note this down. And substances that contract on melting, for example, ice. Ice is going to contract on melting. So the melting point is going to decrease as the pressure increases. Okay, melting point is inversely proportional to the pressure. So it differs. So this is very important. This is quite confusing as well. So effect of pressure, remember this. whichever substance that is going to expand on melting, so the melting point is directly proportional to the pressure. So whichever substance is going to contract means getting smaller in size. Okay, expanding means getting bigger in size. So the substance which is going to get smaller in size on melting is going to be indirectly proportional or inversely proportional to the pressure condition. Okay. Next, the process of changing a liquid into solid by cooling is freezing. Liquid to solid, so it is freezing, or we also call it solidification, and it is the reverse of melting. We all know this. It is the reverse of melting. Okay. Next, intermolecular forces. So freezing point is directly proportional to the intermolecular force. Freezing point is indirectly proportional to the amount of impurities. As the amount of impurities increases, the freezing point decreases. And sodium chloride is sprinkled on roads during winter. Okay, why? Sodium chloride, the rock salt or NaCl is sprinkled on the roads during winter, because it would melt the ice. It would melt the ice so that the roads will not be slippery. Okay, the roads will not be slippery, which means that upon adding the impurities, the freezing point decreases. Okay, the ice wouldn't get solidified when we add impurities to it. The water wouldn't be solidified. The temperature at which solid changes into liquid at atmospheric pressure is dash. Melting point, freezing point. What is the answer? What's the answer, guys? Come on, give me the answer. Is it melting point or freezing point? It's melting point. Okay. So solid changes to liquid. Solid is melting. Okay. Next, liquid to vapor. It is called boiling. We already have discussed this. So before discussing the rest of the concepts, we'll take 5 minutes break. Okay. We'll be back in 5 minutes. Okay, all right, I'm back. All right, let's discuss. Yeah, the boiling. Boiling is the process by which a liquid turns into vapor when it is heated. It's called boiling. It's a type of evaporation. So the factors affecting boiling points are intermolecular force, presence of impurities, as well as effect of pressure. What about intermolecular force? So the boiling point of liquid is directly proportional to the intermolecular force. Why? So the as the intermolecular force will be more in certain cases in some of the compounds, it takes a longer time to boil, okay, to reach the boiling point. In order to break the bond, we need to provide a lot of energy. Okay, that's about the intermolecular force affecting the boiling point directly. Next, presence of impurities. Boiling point of liquid is directly proportional to the amount of impurities. Example, sea water boils at a temperature above 100 degrees Celsius. Okay, above 100 degrees Celsius, the sea water is going to boil. Why? Because it has impurities. Next, effect of temperature. So, if P external, that is pressure, external pressure is less than 1 atmospheric pressure, boiling point of liquid is less than the normal boiling point. If the external pressure is less than the 1 atmospheric pressure, the boiling point of the liquid will be less than that of the normal boiling point. If the pressure, external pressure, is more than or greater than 1 atmospheric pressure, the boiling point of a liquid is greater than that of the boiling point. So, if the external pressure is exactly equal to 1 atmospheric pressure, then the liquid will be, the boiling point of the liquid will be the same. There is no change. Okay, I'm perfectly audible. Moving forward, dash are the intermolecular forces, higher the boiling point. Stronger or weaker? Boiling point is directly proportional to the intermolecular force. So what will be the answer here? Stronger. Okay. Stronger are the intermolecular forces of attraction between the particles. Higher is the boiling point. Next, at Darjeeling, distilled water boils at a temperature dash above 373 Kelvin, above 473 Kelvin, below 373 Kelvin, at 373 Kelvin. Darjeeling, is it a hill station? Think and give the answer. So this is an application based question. Option A. Yeah, option A was the right answer for the previous question. Very good, Tanushree. What about this one? I will be very impressed if you give the answer to this question. We just discussed about the pressure condition, how it is going to affect the boiling point. So it is below 373 Kelvin. Why? Pressure decreases with increase in the altitude. So it is a hill station. As there is increase in the altitude, the pressure is going to drop. The pressure is going to drop. Hence, boiling point will be decreasing. Since Darjeeling is at a higher altitude, water boils below 373 Kelvin. 373 Kelvin is nothing but 100 degrees Celsius. It is going to start boiling below 373 Kelvin. Okay, so let me show you again here the pressure, how it is going to affect it. See here, boiling point is less than normal boiling point when pressure is less than 1 atmospheric pressure. Okay, boiling point will be lesser than the normal boiling point, as the pressure is, external pressure will be lesser than 1 atmospheric pressure. As the altitude increases, what is going to happen? The pressure is going to decrease. Next question. Let's see the next question. Yes. The addition of impurities in a substance results in increase in melting of that substance. Is this true? Yes. Is it true or false? What is the answer? True or false? The addition of impurities. The addition of impurities definitely is going to affect the boiling point, right? But is it false or true? Let me know in the comment section. Okay, we have already discussed this. This is your homework question. Homework question. I need you to answer true or false along with the explanation. All right. Next, which factors increase the melting point? Intermolecular force is going to affect the melting point. Ionic nature of the compound is going to affect the melting point. Impurities are going to affect the melting point. Finally, she is visible after 10-12 years. Come on, hero. I took the class yesterday also. You were not there. Don't put the blame on me. I took the class on Sunday as well. Yeah. So what is the difference between freezing and melting? What is freezing? What is melting? Freezing is nothing but liquid to solid. Melting is nothing but solid to liquid. State change. Okay. His name is Hero and he is from Mumbai. Apparently that's what he said to us. Next, select the correct statement from the following options. The transformation of solid to liquid is called melting and the reverse process is called freezing. What is the answer? Yes. Correct statement. The transformation of solid to liquid is called melting and the reverse process is called freezing. The transformation of solid to liquid is called freezing. The reverse process is called melting. The transformation of liquid to solid is called melting and the reverse process is called freezing. None of them mentioned. Apparently that is his real name, Tanushree. Even that's what I asked him. Okay, he said the same thing. That is my real name. Yeah, what is the answer? Come on, quickly. Option A is the right answer. Okay, transformation of solid to liquid is called melting. Okay, solid to liquid is called freezing. No, this is wrong. Next, transformation of liquid to solid. Is it melting? Yes, it is melting. Then reverse process is called freezing. No. Solid to liquid. It's actually true, right? Yeah. The transformation of solid to liquid is called melting and the reverse process is called freezing. Liquid to solid. It's called freezing or solidification. What is mentioned here? Let's see. The third option. Just give me a second. Yeah. Third option, transformation of liquid to solid. No, it's not melting. No, it's solidification. The reverse, yeah, solid to, yeah, that's freezing, but yeah. Why would you think that, Tanu? Okay, so the debate is about the name now. Alright, come back here. Let's not discuss about the names now. Let's discuss about boiling and evaporation. Boiling refers to a change from the dash. Solid to a liquid phase, vapor to a liquid phase, liquid to a solid phase, liquid to a vapor phase. Yeah. What's the answer? Boiling refers to a change from the dash. Solid to liquid, vapor to a liquid, liquid to vapor. What is the answer? Option D. Very good, Tanushree, very good. Option D is the right answer. Yes, liquid to vapor. Let's summarize. We have discussed about boiling and evaporation in today's class. So boiling, process of liquid changing into vapor when the liquid is heated to its boiling point. The boiling occurs at boiling point. Okay. Okay. Alright. Yeah. Next, process of liquid changing into vapor even below its boiling point. So that is evaporation. Okay. So what are the factors that affect evaporation? Temperature, surface area of the liquid, wind speed and humidity. All these three are going to increase the rate of reaction. Rate of evaporation. Okay, as the temperature or surface area or wind speed increases, the rate of evaporation increases. Humidity, on the other hand, it decreases the rate of evaporation as it increases. Okay. Hero is not studying in 9th or 10th class. He is preparing for competitive exams, I suppose. Yeah. Moving on. Factors which affect melting point. Ionic bonds, intermolecular force, presence of impurities and effect of pressure. And yes, factors which affect freezing point, intermolecular force and presence of impurities. On the other hand, boiling point, effect of pressure, intermolecular force, presence of impurities. Effect of pressure is quite tricky in case of boiling point. You have to be very thorough with that. Okay. Alright. Hi Piyush. Hello. Next, previous year question. So we'll solve a couple of problems for practice and we'll discuss previous year questions. Alright. Understood? Recorded class hai? Nahin. It's not recorded. It's a live class. Live class. Yeah. Evaporation is a bulk phenomena. True or false? Is it bulk phenomena or a surface phenomena? Give me the answer. Who told you that I'm preparing for that? Okay, Navya ma'am was mentioning about that. Apparently, in one of her classes, you mentioned the same thing, that you are preparing for some competitive exams. I don't know. She mentioned that. Hello, Anup, hi. You're late to the class. Why, Anup? Very good evening. Very good evening, Anup. Hello. Yeah. What is the answer, guys? Come on. What is the answer here? Option B is the right answer. It is false. Evaporation is a surface phenomena while boiling is the bulk phenomena. Okay. What is it? Network problem. Okay. No problem. Is it sorted now? Yeah, it is false. Next, two beakers A and B contain distilled water. 0.2 grams NaCl is added to the beaker A and both the samples are allowed to freeze at the same experimental conditions. It is observed that dash. So there are two beakers, guys. I'll change the color here. There are two beakers A and B. Okay, both of which contain distilled water. Both of them contain distilled water. I'll write DW. Okay, distilled water. For beaker A, they have added 0.2 grams of NaCl. NaCl is the impurity. How is it going to change the, freezing point? They are allowed to freeze. Yeah, what is the answer? Question, option C is the right answer. A freezes at a lower temperature than B because the impurities are going to affect the freezing point. As impurities increases, the freezing point decreases. Not option A. Option C is the right answer. Okay. So as the presence of impurities lower the freezing point, it decreases the freezing point. It is inversely proportional. Remember this. This is an application based question. Okay. Yeah. boiling point of 4 liquids A, B, C and D are given. Arrange them in the decreasing order of the intermolecular force of attraction. So I'll give you a hint here. Intermolecular force of attraction is directly proportional to the boiling point. Force of attraction, it's directly proportional to the boiling point. So if you see a substance having more boiling point, you can assume that it has more intermolecular force of attraction. Okay, yes, Anup and Tanushi Yadav. For the last question, the C was the right answer. Where can you get the notes? I'm really sorry, I totally forgot to attach these PDF in the description. We'll do that tomorrow, definitely, I promise you. Okay, yesterday's and today's class notes, I'll be attaching that in tomorrow's description. I'll be coming live almost around the same time. Okay, yeah. What's the answer? Madam, B. Is it B? Okay, A has 33 degrees Celsius as its, okay, let me write here, it's all shuffled. 33 degrees Celsius. Next, B has 175 degrees Celsius as its boiling point. Then, then we have C. C has 100 degrees Celsius. Next, D. Oh, I can't see D. Okay. Where is D? It is 72 degrees Celsius. What will be the answer? Now tell me the answer. Starting से शुरू कर दीजिए please. No, it's already more than 1 hour. Anup, please rewind the class and watch it. Okay, rewind the class and watch the class. Okay, yeah. What will be the answer? Option A will be the answer. B, C, D, A. Why? So B has the highest boiling point, which means that the intermolecular force of attraction is highest in that. Decreasing order means highest to lowest. Okay, and then C has 100 degrees Celsius. That comes next, and D has 72 degrees Celsius boiling point. D sample. Okay, first B, then C, D, and then last A. A has the lowest intermolecular force of attraction amongst these. Hi. Vedantu KRD ma'am. Moving on, which of the following statements is not true? The rate of evaporation is more in coastal area than in non-coastal area. Rate of evaporation is more in hot sunny days than in rainy days. Water kept in earthen pot gets cooled due to evaporation of water from inside the pot. Rate of evaporation is inversely proportional to humidity. Which statement is not true? Which is false, they're asking. So in coastal areas, humidity will be more, guys. Remember this. Humidity is more. So how humidity is going to affect the rate of evaporation? Oh, I'm really sorry, but I didn't block you yesterday. Vedantu KRD ma'am. What's your actual name? Is it Shreyansh? Yeah, Anup is actually typing in cursive and it's incredibly difficult for me to read it. I swear I'll not block you. Okay? Why would I do that? Yeah, tell me the answer for this one. You're engaged in, other conversations rather engaging yourself in answering these questions. Come on. Is it Munawar or Munwar? Is it Munawar or Munwar? कुछ समझा नहीं आ रहा है. Okay, so you should have joined the class early, Anup. We are already, quite. We have already discussed about the factors affecting boiling point, evaporation, melting point, and freezing point. You can rewind the class after the class ends, and you can Munwar. Okay, cool. You can you can rewind the class and watch it. Okay, because it will be incredibly difficult for me to go back again and teach everything that I have taught in 1.5 hours. Munwar, cool. Yeah, tell me the answer for this one. Option D. Option D. Option D. No, 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 no. It's not option D. Rate of evaporation is inversely proportional to the humidity. This is true. They are asking which is not true. Water kept in earthen pot. This is also true because of evaporation. Rate of evaporation is more in hot sunny days than in rainy days. This is also true because as the temperature increases, rate of evaporation increases. Okay. Next, the first one is false. The rate of evaporation is more in coastal area. No, coastal areas means which has sea. Okay. In coastal areas, the humidity is extremely high. All right. Yeah. Ma'am, for how much time that deleted messages hold on there? As soon as you delete it, it will be deleted. But I have a, very quick sense of seeing. I just see on the screen. All right, moving on. Which of the following statements is not true? In coastal areas, humidity is more as compared to non-coastal areas. Hence, rate of evaporation in coastal area is less as compared to non-coastal areas. Okay. Okay, Tanushree, it's not how it works with Hero. I'll tell you how. So, if it is academic, he is going to keep the messages. If it is not academic, it is non-academic, he is going to delete the message. You can check it. So he's a regular person who watches our videos, who comes to our class. So it's quite evident. You're preparing for MCET. Okay. That's cool. Very good. All the best. Do well. So basics are very important for your competitive exams. You cannot possibly understand the higher level concepts if you are not thorough with your basic concepts. It's going to be incredibly difficult for you. Okay? Yeah. Moving on. The kinetic energy of the gas molecules decreases with dash. Increase in temperature, decrease in temperature, temperature independent, none of the above. Decrease. When does kinetic energy decrease? Yeah. Tell me. When is it going to decrease? You can listen to the class, of course. Yeah, definitely, most definitely. Munwar, you can listen to the class and engage yourself in answering the questions. Okay? Option A. Anup is saying option A. Pranya is saying option A. Then it must be option A. Is it option A, guys? Kinetic energy decreases with decrease in temperature. Okay, don't get confused. So with a decrease in temperature, kinetic energy is going to decrease. I'll tell you how. So evaporation, for example, evaporation, how does it occur? So this is a pot or something, some vessel. Okay, there is water in it. Only when the temperature increases, the particles, are going to start moving faster, and they are going to overcome the force of attraction and going to get changed into liquid to gaseous state only when the temperature increases. So of course, as the temperature increases, the kinetic energy is going to increase. Okay, write this down. Don't get confused about this because this is very important and very, very basic. Kinetic energy increases as the temperature increases, which means that it is directly proportional. Okay. Yes. Next. Okay. Richa visited a natural gas compression unit and found that the gas can be liquefied under specific conditions of temperature and pressure. While sharing her experience with friends, she got confused. Help her to identify the correct set of conditions. how we can compress the gas. We can compress the gas, right? Gases are compressible, highly compressible. That's how we fill that in our, cylinders. But what are the conditions that is necessary to compress the gas? Increase in temperature, decrease in temperature, or what about the pressure conditions? Okay, thank you so much for that. Yeah, I try to be sweet. I mean, in the world, that you can be anything, be kind, right? D, madam, is the D. Low temperature, low pressure, high temperature, low pressure, high temperature and high pressure. It is C, low temperature and high pressure. We have to lessen the temperature. We have to lower the temperature. Liquefy means that gas to liquid must happen. When is that going to happen? We need to decrease the temperature. Only then liquefaction going to happen. Okay, and we need to apply the pressure in order to compress that. When we, for example, see here, this is a container, okay, inside which there is gas. The gaseous particles are randomly moving, right? They possess so much kinetic energy. Only when we apply pressure, it can be compressed. It can be compressed. We need to apply pressure. Okay, understood? Tanushree is from Andhra Pradesh. Yeah. Note this down. Tata Hero. I would say stay till I finish the class, but yeah, it's your wish. Next question. During summer, water kept in an earthen pot becomes cool because of the phenomena of dash. Diffusion, transpiration, osmosis, evaporation. What is it? Definitely not diffusion. Diffusion is intermixing of particles. Then, yeah, please don't go. Stop. Listen to your last brain cell. What is the answer? Option D is the answer. Evaporation. Okay, cooling of water inside the earthen pot is because of evaporation. The earthen pot will have small pores, tiny pores. The water kept in an earthen pot seeps into the small pore in the pot and evaporates from the surface of the pot. The heat required for evaporation is taken from the water inside the pot, thus cooling the water stored inside. Okay, this is why the water is going to remain cooled. Option D, yeah, option D is the right answer. Very good. Pranya, very good, very good. Awesome. Keep it up. Next, which of the following will not sublime? Which is not a sublimable substance here? Tata Hero. I'm sad that you are going, but yeah, what can I do? Camphor, ammonium chloride, bromine and iodine. Which doesn't undergo sublimation. Sublimation is nothing but solid to directly gas. Solid to gas. Option A. No, not option A. Is it camphor? No. It is sublimable. They are asking not sublime. Which will not sublime? What is the answer? Think. Camphor, karpura. So, yeah, karpura, that's what we call in Kannada. Camphor, which is used to do puja. So, it is a sublimable substance. Okay. Ammonium chloride, NH4Cl is also sublimable. Iodine is also sublimable. So, it is bromine. Bromine doesn't undergo sublimation. Okay. What is it? मिस आज लास्ट क्वेश्चन के बाद एक शायरी सुना दीजिए. Oh, I'm not a शायर. No, I'm a singer, but I cannot compose poems on anything. Yeah, I'm not a poetess. Option D is the right answer, okay? Sorry, C is the right answer, bromine. Next question. The factor responsible for converting one state of matter into another. Change in temperature, change in pressure, both A and B, change in humidity. What is shairi? Shairi is poem. Poems. And I would request Anup to not, not use the cursive handwriting because it's incredibly difficult for me to read it. Okay, so there is a desktop, there is a a screen here. Okay, quite far away from me. I need to look at that and read it. If you use cursive, I will not be able to read it. Please use the normal the letters font. What am I interested about, Munwar? I don't understand. What are you asking? Be specific about your question. Miss Google say. Okay, I'll try then. Yeah, what is the answer for this question? Factor responsible for converting one state of matter into another. It's option C, both A and B. Temperature and pressure are the two factors responsible for converting one state into another. Okay. Next question. In which of the following conditions the distance between the molecules of hydrogen gas would increase? Increasing pressure on hydrogen contained in a closed container. Some hydrogen gas leaking out of the container. Next, increasing the volume of the container of hydrogen gas. Adding more hydrogen gas to the container without increasing the volume of the container. Yes. The distance between the molecules of hydrogen gas would increase. Distance increase. When is it going to happen? Is it option C? 2 and 3, 1 and 3, 1 and 4, 2 and 4. So on increasing the pressure, the distance decreases. Okay, so it's not the answer. Next, some hydrogen gas leaking out of the container. Yes. So when few of the hydrogen gas molecules are going to leak out of the container, the more space will be there for the remaining hydrogen gas molecules. So yeah, distance might increase. And then increasing the volume of the container of hydrogen gas. Yes. If we increase the volume of the container, more space is going to be there. So what will be the answer? 2 and 3. Okay. C is the right answer. C. Okay. Yeah. Anup was right. C is the right answer. Even Pranya also gave the answer. Tanushri, good. All of you, very good. Very good. Keep it up. Next question. Which of the following sets of phenomena would increase on raising the temperature? What will increase when we raise the temperature? Diffusion, evaporation, compression of gas. Evaporation, compression of gas, solubility. Evaporation, diffusion, expansion of gas. None of these. Yeah. So as the temperature increases, does diffusion increase? Yes, diffusion increase upon increasing the temperature. Why? The kinetic energy is going to increase, which means that the particles are going to move at a faster rate. Okay. You should fall in love with a subject, not with a teacher. Come on. Yeah, you should fall in love with a subject, not the teacher. Yeah, what is the answer? Diffusion. Yeah, diffusion is directly proportional to the temperature. Okay. Next, evaporation. Yes, evaporation also is directly proportional to the increase in temperature. Okay. Next, what about compression of gas? If we increase the temperature, compression is going to happen or not? No. Okay. No. Next, solubility. Yes, solubility is also directly proportional to the rate of, solubility is directly proportional to the temperature. Okay, as the temperature increases, the solubility increases. So what will be the answer? Option D, none of the above. Option C is the right answer. Okay. Yes, evaporation increases with increase in temperature, diffusion increases, expansion of gases increases. The gases are going to expand upon increasing the temperature. But here they have given compressibility of the gases. Compressibility of the gases increases with decrease in temperature. Okay? So option C is the right answer. Understood? What is this? Next, maximum intermolecular force of attraction exists in dash bromine, A, oxygen, copper. So which has the highest melting point here? That will have the highest intermolecular force of attraction. I'll tell you. So the state, okay. Bromine is a liquid at room temperature. Air is a, of course, gas. Okay, gas at room temperature. Oxygen is a gas at room temperature. Copper is a solid. Solids have the highest intermolecular force of attraction. Then comes liquid and then gases. Okay? Yeah. Which is the answer? Which is the answer? Option D. Absolutely right. Very good. Option D is the right answer. Next, the boiling point of water at sea level is dash. Sea level. What will be the boiling point of water? Not the sea water. At the sea level. It is 373 Kelvin. Okay. The boiling point of water at sea level is 100 degrees Celsius. Alright. Sea level. As the altitude increases, the pressure is going to drop down. That's why as the pressure decreases below 1 atmospheric pressure, then the boiling point of water will be decreased. The boiling point will be decreased. Okay. We have discussed this. Next, yeah, previous year questions. We'll discuss a couple of them and then we'll wind up the session. The lowest energy state of matter is dash amongst liquid and solid. Which has the lowest energy state of matter? Option C. There is no option C. Hi Komal, hello. Hi. Is it B? Yeah, it is B. Option B is the right answer. That's solids. Very good. Very good. Keep it up. Your name is Krishna. Okay. Hi, Krishna. Hi, Krishna. Yes. Solid. Yes, it is solid. Very good, Pranya. Next. A drop each of two non-corrosive and non-irritating liquids A and B at temperatures of 22 degrees Celsius are placed on the skin. Okay. A and B. They both are non-corrosive and non-irritating. That's A and B. A is producing more cooling effect than B, which means that A is getting evaporated at a faster rate. A is getting evaporated at a faster rate. That's why it is causing more cooling effect. So what will be the answer? Tell me now. नव्या मैम का क्लास कब है? नव्या मैम का क्लास she will be starting the class soon. Okay, biology. Yeah, we'll ask her and we'll let you know. And please turn on the notification so that you will be notified about all the classes that will be happening in the channel. You are going to select option A, option B. Okay, is it option B? Liquid A has higher latent heat of vaporization than that of liquid B. Okay, option C is the right answer, guys. I'm really sorry nobody answered that. But yes, liquid A has lower latent heat of vaporization than that of liquid B. That's why it is getting evaporated at a faster rate. Okay. Next, yeah, liquid A gives more cooling sensation than liquid B, means that liquid A is early vaporized than liquid B. Okay, thus liquid A has less boiling point and lower latent heat of vaporization than that of liquid B. Option C is the right answer. Moving on. What happens when a fixed amount of oxygen gas is taken in a cylinder and compressed at constant temperature? Number of collisions of oxygen molecules at per unit area of the wall of the cylinder increases. Oxygen gets converted into ozone. Kinetic energy of the molecules of oxygen gas increases. What is the answer? Yeah, what is the answer? What will happen when oxygen gas is taken in a cylinder and it is, compressed at a constant temperature? It is being compressed. Pressure is increasing, but the temperature is constant. What is the answer? Oxygen gets converted into ozone. No chemical reaction is happening here. Okay, this is wrong. I have eliminated it. Let's see in first and second which is the right answer, or both of them are. Let's see. Who is going to answer now? Give me the answer. Option C is the right answer. Third only. Kinetic energy of the molecules of oxygen gas increases. One only. So kinetic energy increases with increase in temperature. With increase in temperature. Okay. Here the temperature is constant. My dear students, the temperature is constant, so kinetic energy is not going to be affected. Okay? Yeah. So number of collisions of oxygen molecules at per unit area of the wall of the cylinder increases. Why? Pressure is applied. So oxygen molecules were like this in the cylinder. I'll show you. So this is the cylinder. Oxygen molecules were like this. Okay. When you apply pressure here, so when the pressure is applied, the oxygen molecules are going to collide with one another because there is no space. Okay. So option D is the right answer. One only. Moving on. Some ice pieces are kept at a temperature minus 5 degrees Celsius, are heated gradually to 100 degrees Celsius in a beaker. The temperature of the contents are plotted against time. The correct plot is dash. What is the correct answer here? See the graph and give the answer. So ice pieces are kept at a temperature minus 5 degrees Celsius. At minus 5 degrees Celsius, they are still going to be ice. They are still going to be solids. Okay. So it is gradually heated to 100 degrees Celsius. See the graph and give me the answer. See here. At, yes, the temperature here it's mentioned and the time. Okay. So this is for 0 degrees Celsius. Okay. And this for 4 degrees Celsius. Next 100 degrees Celsius. There is something here. Graph is moving like that. What will be the answer? Option C will be the right answer. Okay. Why? Due to latent heat, the temperature remains constant during state conversion. So during state conversion of state of a substance, the temperature is going to be same. Okay, the temperature is not going to increase. The temperature, the energy that is provided is utilized for converting the state, not increasing the temperature. Conversion is going to happen with the energy that we have provided. Okay, so this will be the right answer. Okay, here, see, at 0 degrees Celsius, it's still going to be, ice. After it is, all the ice is melted, then it is going to remain in liquid state till it reaches 100 degrees Celsius. At 100 degrees Celsius, it's going to start boiling. It's going to start boiling. Okay. So here it is solid. Okay. Till all the solid ice is melt into the liquid, it is going to remain in 0 degrees Celsius. Only after all the, all the ice is melted, it is a liquid and it is going to increase the temperature. it reaches up to a point where it starts to boil. Okay. Moving on. Which of the following are the correct examples of matter? Glass bottle, water, noise, air, wood and vacuum, silver foil, hot air and chalk, sand, oxygen, light flash. Light flash is not a matter because it doesn't have any volume. Okay. What about vacuum? What about noise? Option C is the right answer. Okay. So matter is any substance that has mass and volume. It should have mass and volume. It should occupy some space. Okay. Option C is the right answer. Not B. It's option C. Option C. So vacuum is a, where there is nothing, that is vacuum. There will be no air, there will be no water, nothing. Okay. Next, moving on. Solids have strong intermolecular force of attraction. True or false? What is it? Solids have strong intermolecular force of attraction. This is absolutely true. Okay. True. This is right. When water at 0 degrees Celsius freezes to form ice at the same temperature of 0 degrees Celsius, then it dash. Water at 0 degrees Celsius freezes. Okay. At the same temperature of 0 degrees Celsius. So what does it mean? Then it absorbs some heat, releases some heat, neither absorbs nor releases heat, absorbs exactly 3.34 into 10 raised to 5 joules per kg of heat. What is it? What is the answer? Come on. Give me the answer. Option B. It releases some heat. Okay, when water at 0 degrees Celsius freezes to form ice at the same temperature of 0 degrees Celsius, then it is going to release some heat. Okay, so at 0 degrees Celsius, water discharges some heat to decrease the speed of the molecules. In order to decrease the kinetic energy of the respective particles, it is going to give out some heat. Only when the kinetic energy of the particles is decreased, the state of the matter is going to change. Here, from liquid to solid needs to happen, which means that kinetic energy should be decreased. Okay, the particles will not be moving in solid state as much as in liquid state. Okay. So when the water is cool enough, its molecules are fixed at one position and they begin to vibrate, which means that it is in solid state. Okay. Moving on. This is your homework question, guys. I need you to answer this in the chat section. Comment section, not in the chat, but comment section. Okay, I'll explain you this. Which of the following statements are true? They're asking about true statements. On heating, the kinetic energy of the particles in solids does not change because they have a fixed position. Is this true? Think and give the answer. Next, sublimation is a change of solid state directly to gaseous state without going through liquid state. Is this true? They're saying solid to directly gaseous state. Okay, that is sublimation they're saying. Next, the movement of particles from an area of higher concentration to lower concentration is called diffusion. Is this true? Diffusion is the intermixing of particles. From where the particles are going to move from higher concentration to lower concentration. This is the hint that I am giving. This is true. This is true. Third one is true. Next, fourth one, the rate of evaporation is not affected by increasing the temperature. Is this true? Give me the answer. Yeah, tell me the answer. I know you are not going to do your homework, so tell me the answer right away. Ha, what is the answer? Option C is the right answer. Option D is the right answer, guys. Second and third. Okay, the rate of evaporation is not affected. It is affected. Okay, they are asking true statement. So this is not true. First one is also not true. On heating, the kinetic energy definitely increases. Okay, so this kinetic energy is used to overcome the force of attraction, and the solid will be getting converted into liquid state after attaining the enough temperature, after attaining the enough kinetic energy. Okay, so option 2 and statement 2 and 3 are correct here. Cool. I already told you, right? You can easily eliminate. See, wherever there is wherever there is no third option, it is wrong. So we can eliminate this. We are left with 3. Okay, so this is an easier one. Rate of evaporation. The temperature is going to affect the rate of evaporation. So wherever there is fourth option, you can eliminate that. We can eliminate this one. Okay, we are left with these 3. This is how elimination works. Okay. Next, the rate of evaporation increases with dash. It increases with what? Tell me the answer. Give me the answer. This is very simple. Increase of surface area, increase of temperature, decrease in humidity, increase in wind speed. It is option A. Option A itself is the right answer. Temperature, surface area, wind speed. All these increase the rate of evaporation, but not the humidity. As humidity increases, the rate of evaporation decreases. Okay, Miss Shairi. I don't know about Shairi, but I can sing. Okay. The rate of evaporation increases with increase in surface area. I already told you. So let's summarize part 1 as well as part 2. So we discussed part 2 today. Yesterday we discussed part 1 of this chapter. Okay, go check that out, guys. That's also very important. We discussed a lot of things yesterday. So matter is made up of particles. The matter are very, very tiny. The particles of matter has space between them. It is called interparticle space. And then the particles of matter are continuously moving, and the particles of matter attract each other. This is nothing but interparticle force of attraction. Okay, the particles are continuously moving. They are in motion. Understood? Yeah. Next, we have discussed the classification of matter. We have discussed in detail about solids, liquids and gases, but a brief introduction about plasma and Bose-Einstein condensate. Okay, in plasma state of matter, the particles attain very high energy and they're always excited. Understood? Yes. Next, what is it? Miss, last question के बाद क्या? I don't understand. Yeah, characteristics of solids, we have discussed this. Characteristics of liquids as well as gas, we have discussed this as well. Next, interconversion of 3 states of matter. So liquid to gas, gas to liquid, solid to directly gas, it's called sublimation. This is something that we have discussed in the previous class. And formula for converting temperature, this is super important, guys. You need to know this. In order to do calculations in your higher grades, in your competitive exams, this is super, super important. Okay. Next, boiling and evaporation, the difference between boiling and evaporation. Okay. Yeah, boiling occurs at boiling temperature, boiling point. Evaporation can occur at any temperature below boiling point. And what else? Evaporation is a surface phenomena, while boiling is a bulk phenomena. Okay. Next, factors which affect melting point, ionic bonds, intermolecular force of attraction, presence of impurities and effect of temperature. You need to revise this again, how they are going to affect the melting point. Okay, if we talk about freezing point, intermolecular force and presence of impurities are going to alter the freezing point. They are going to affect the freezing point. Okay. Shairi is poem in Hindi, but I don't know Shairi. Okay, I'm not a Yeah, poetess. Next, factors which affect boiling point. Effect of pressure. Pressure is going to affect the boiling point. Intermolecular force and presence of impurities. Revise this again. So yes, please do subscribe to the channel. Okay, and turn on the notification button. And it was very fun, today. And but also indulge yourself in more. Answering more. Okay, answer more in the class rather discussing something else, because the competitive exams are going to be really tough. There is so much competition. There are a lot of lakhs together students writing the competitive exams. Okay, you cannot be you cannot be wasting your time. Okay, yes, thank you so much for joining me today. Wow, you're talking about girlfriend and boyfriend on the chat, really? Come on, guys, you're still in high school. You still have time to do all those things. Now study. Study well as of now. Okay? Yeah. All right then. Bye bye. Thank you so much for joining me today. All the best, guys. Study well. Don't waste your time.